Okay, so now that we've kind of covered some of the terminology we're going to be using, and you'll see it's kind of labeled here, we're going to talk about how to use this to help us find values of trigonometric functions. If you look at the word trigonometric, right, it comes from the word trigonometry, which is basically a if you think about like metrics, right, meter, it has to deal with measures and things of, and then trig, right? Well, think of tri. So it's basically measures of triangles, and it's things doing that. But what makes trigonometry different from like the Pythagorean theorem or some of the other work you guys have done with triangles is that it's actually using things, ratios and things that have been calculated over time and all this. So it's a slightly different application of it. So we're just as a reminder, this is called theta, okay? And then adjacent and opposite are, adjacent means next, opposite means across. The hypotenuse, right, comes from the Greek and Latin word root, hypo, which usually means long, right? And then tenuse is kind of another way of saying like a side or a length or a part, right? Or a leg, something like that, right? So, and then this right here is our right angle sign. So that's our right angle, right? That's 90 degrees, if we don't remember. Okay, and then A, B, and C are, you know, more or less kind of arbitrary here for what we're doing, but they would be the other names for the angles there. So angle C would be that, angle A would be this, angle B would be theta in this case, and then your legs would be labeled according to that. So now when we talk about the trigonometric function is defined by a ratio of two sides in a right triangle relative to an angle. So it has to be related to the angle. So the sine of this angle is going to be different from the sine of this angle, right? Because the adjacent and the opposite have to be related to the actual angle you're speaking of, right? So when we write these, we usually abbreviate them to 3 letters. And that'll be the case for 5 of these, and then cosecant we do differently because it looks like cosine if we shorten it. So cosecant is always going to be CSC, right? Everything else is just the first 3 letters. So sine of theta, that's how you make a 0 with a line through it, is equal to, so hopefully you're listening and paying attention now, we are going to take this and it is always going to be the opposite leg over the hypotenuse, right? So it's opposite over hypotenuse. Okay, and we'll talk about kind of a way to remember this in a minute that you guys probably all know and probably all complain about, but it works. So now we've got the cosine of an angle, right, is the other relationship that uses the hypotenuse. So it's the adjacent leg over the hypotenuse. And remember, the hypotenuse is always the longest leg, right? So these ratios are always going to be smaller than 1. Okay, because you have the smaller leg over the bigger leg. Think about how division works, right? So it's the adjacent leg over the hypotenuse. And then your tangent is kind of the wild card of these because it doesn't use the hypotenuse, right? The tangent is always the opposite over the adjacent. So it's always opposite over adjacent. This is the one that I have the hardest time remembering, which is where SOH-CAH-TOA comes in, all right? So what is SOH-CAH-TOA? And most of you know it, but what it is it's saying it takes the first letter of these relationships. So it always goes, this is always the first letter, this is the second letter, and this is the third letter. So you have so, right? So sine, opposite hypotenuse. And then here we've got 1, 2, 3. So this is CA, all right? So this is cosine adjacent hypotenuse. And it's hard because you don't necessarily hear the H, but you just got to kind of remember it's there. So SOH-CAH, and then we have TOA, all right? And so TOA is tangent or opposite, or equals the opposite over the adjacent, right? So TOA. So when you hear, oops, don't want to do that. when you hear that that mnemonic, right? SOH-CAH-TOA. That's what we're talking about. That's what it means. This is just a way to remember these ratios, right? So you'd say SOH-CAH-TOA, SOH-CAH-TOA. So if somebody says cosine, you go, all right, so it's not that one. There's no C cosine. So it's always the first letter. So you got sine, cosine, tangent. So cosine, you go, all right, ka. Well, the next sound is an A sound, right? So that would have to be adjacent. And then because it's not like SOH-CAH-TOA or SOH-CAH, right? If it's SOH-CAH, that means your H, your hypotenuse, right? So same with sine, so SO, right? So you got to kind of understand how sounds work, how phonics work a little bit for this to make some sense. Most of you have a pretty rudimentary sense of that, so we'll be good. So that's how you remember these, right? And now when we talk about cosecant, secant, and cotangent, these are really, and they're kind of lined up this way for a reason, right? And you're just, honestly, these you're just going to have to remember. The cosecant, the way I remember cosecant away from secant is, well, actually, I don't. I take that back. I always relate secant to cosine. And cotangent's easy because cotangent sounds like, oh, okay, that's cotangent, you know, cotangent, right? You think tangent. So these, all three of these are reciprocal functions of these, all right? So this is the cosecant is a reciprocal function of sine. The secant is a reciprocal function of cosine, and the cotangent is a reciprocal function of tangent, right? And so basically, what do we think of when we think of reciprocal? When you think of reciprocal, I hope by this point you think of flip, right? You just kind of take a fraction and you turn it around so that what was in the numerator is now in the denominator and vice versa. So the reciprocal function of sine, so cosecant, we write this like this, is basically take your sine function and then flip it. So this becomes the hypotenuse over the opposite, right? And so they don't use like a mnemonic for this one, like I said, right? And then secant, right, is basically the flip of cosine. So take that, so it's hypotenuse over adjacent. So if you know your first three functions pretty well, you'll be able to usually find these, provided you can remember that secant relates to cosine, cotangent obviously relates to tangent, so therefore by the process of elimination, cosecant has to relate to sine, right? And then cotangent looks like cot, all right? And that is, flip this around, right? So it's adjacent over opposite. And this is the one I have the hardest time remembering because to me, it seems like tangent should be adjacent over opposite just because of alphabetizing it, but that's not how it works, right? It's opposite over adjacent for tangent, and therefore cotangent is the opposite of that. It's the reciprocal function of that. So it's adjacent over opposite instead. So these are the basic functions. These are the 6 functions you're going to use. You are going to use these 3 way more than you use these in any kind of regular practical applications. In physics, I will tell you from my experience with that, having taken a couple physics classes in college, that you almost never deal with these, right? It's pretty much always these. And I'm not saying these aren't useful. They are useful. But for the most part, sine, cosine, and tangent are going to be your bread and butter with trigonometry. We just got to kind of know these because sometimes when things get flipped around and stuff like that, it's easier to refer to them this way rather than saying, oh, the inverse of sine, right? Or the inverse or flipping sine. Sorry, not inverse. Inverse is the wrong word. The reciprocal of sine or the reciprocal of cosine, the reciprocal of tangent, right? So that's why these are helpful. And but like I said, if you know these 3, you're in good shape. All right. So I'm going to stop the video here, and then the next video we're going to just do an example of these in action, and then we'll move on.